Hello. Today I'll be doing Chapter 6 review. So, Chapter 6 was all about gases. So, we're learning about different laws, different forms of pressure. We're learning about gas reactions, diffusion, effusion, ideal gas laws, standard temperature and pressures, and everything in the works. So, to start off, gases are very strong moving particles and are usually very light. And they move in a straight line, but when they begin to rise up, they begin to collide. And there's lots of empty space in a container when it comes to gases. And the pressure of gas, P equals the force divided by the area. And the force is in newtons, and the area is M2. And the units of pressure, 1 atm is like the standard pressure. So 1 atm is 1 atmospheric pressure. And there's also different conversions, like 760 mmHg is equal to 1 atm, and 1 mmHg is equal to 1 tar as well. So there's different things that we can use here. And then we also have devices for pressure, and there's a manometer, which basically is like, it looks like a U tube here, and then it contains mercury, usually contains mercury within it, and it's used to measure the pressure of gas in a container. So we have a U-shaped container here. It has a little section here that usually contains the gas here. And then, according to Boyle's law, at constant temperature, the volume of gas is inversely proportional to the pressure of gas. So, an increased pressure equals a decreased volume in that sense. And one of the formulas for Boyle's law is that V is proportional to 1 over P. So, V equals K times 1P, and K is just any form of constant. So, P1 V1 is equal to P2 V2. Moving on, we also have Charles' law. So Charles' law says that for a fixed amount of gas at constant pressure, the volume of gas is directly proportional to the temperature in Kelvin. So normally they'll give temperature in Celsius, and we have to convert that to Kelvin. And we know that in order to go from Celsius to Kelvin, you have to add 273 to that value. So for that, V is constant times T. So V divided by T equals constant, or V1 divided by T1 is equal to V2 divided by T2. And Charles' diagram is usually, first it has a little diagram here, and there's straight lines that pass through 0, and that is, the 0 represents the absolute 0 point, and it's the lowest possible temperature within the situation here. Next we have Avogadro's law. So Avogadro's law, we've kind of spoke about that before, when it came to, I believe, moles, conversions of moles, yes. And then at constant pressure and temperature, the volume of gas is directly proportional to the number of moles and molecules as well. And mathematically, V is proportional to N. So V1 divided by N1 is equal to V2 divided by N2. And then for his diagram, there is 1 mole of gas has a volume of 22.4 liters. So the standard volume for gas is 22.4 liters. And standard pressure is 1 atm. Moving on, for ideal gas law, it combines all these gas laws into one. And now it gave us the equation of PV is equal to nRT. And R is a gas constant, which is 0.082 or 0.08205. And then if we're trying to find finding values with different values, so basically if like temperatures change, like temperatures are increasing, temperatures are decreasing, we can use P1 V1 equal to divided by T1 equal to P2 V2 divided by T2. And then the standard temperature is 0 degrees Celsius or 273 kelvins. Standard pressure is 1 atm, and molar volume is 22.4 liters of gas. And then to find density at standard pressure, we have to use molar mass divided by the molar volume, which will give us our density. And density also equals the molar mass times R divided by, molar mass times the pressure divided by R times the temperature. Moving on, we also have Dalton's law of partial pressure, and it says that the combination of individual pressures of availability gases is equal to the total pressure of a system. So basically, if we were to have gas 1, gas 2, gas 3, gas 4, and then we add all those up, we can divide it by RT divided by V. So R is like our standard gas pressure, T is our temperature, and V is our volume. And so we can like add them up, all the normal pressures, volume, add them up, times it by RT and divide it by V. And gas reaction is possible to find number of moles of gas if PV and T of the gas is given. So PV divided by RT is equal to the moles. And then lastly, we've talked about diffusion and effusion. So diffusion is a process of a collection of molecules spreading from high concentration to lower. And effusion is a collection of molecules. A collection of molecules escapes through a small hole into a vacuum, and the rate of diffusion and effusion of gas are related to their RMS, which is the root mean square average velocity. And then we have Graham's law of diffusion, where the square root of 3RT over MA times MB divided by 3RT is equal to MB squared over MA squared. And that is all for chapter 6.